Okay, I just wanted to go over this book real quick. I wonder if this guy's related to Pascal Jordan. I doubt it. But I'm just building on the Greek physics or philosophy of science professor who points out that the time frequency uncertainty originates from noncommutativity. But this was covered up when the matrices were used to then have a identity matrix. And I never explain what is meant by an identity matrix. So I want to go into that. The key point here is when you're with time frequency uncertainty, you're dealing with the imaginary number. And as this book explains, when you're dealing with 1/2 spin, Pascal Jordan, he said that corroborated his claim for the need for a noncommutativity as the foundation of nonlocality. And so when you have the matrix as based on -1 as the identity matrix, that's because when you use the imaginary number as I or -I, when you square it, you still get -1. So that's how you get the identity matrix using -1 as a square of 180-degree rotations. Here we do not consider such big rotations. The identity rotation is represented by the matrix 1, not -1, and every small rotation by a matrix that differs from 1. So when you're not using the -1, then you can cover up the fact that the imaginary number, is actually the phase of the time and frequency. And so when you have the phase of the time and the frequency, that's what's inherently noncommutative and non-local. And so that's why when you have an identity matrix, it's the same thing in music theory. When you say that 2/3 times 3/2 equals 1, that's the equivalent of an identity matrix. It's just the inverse value. But in music theory, the 2/3 is C to F as undertone and 3/2 is C to G as overtone, and they're both the perfect fifth, but they cannot equal 1 because they're inherently non-commutative. So that's the same situation you have with when you're using the imaginary number as your phase change. So what anyway, I've talked about that before, so I wanna get to a point in this book, if I can manage to turn the pages one-handed. There we go. But I had looked at this book before, and he doesn't use the term non-commutative. I think he only used it like once, but it turns out that Wolfgang Pauli was a year and a half older than Heisenberg. And so what happened is that Heisenberg asked for Wolfgang Pauli's help, and Pauli, he didn't want to get involved, but he was willing to critique their work, and so that's what led Pauli to then develop the matrices for spin. Let me see here. Okay, I'm not quite there yet. I gotta go back farther. Yeah, okay, I'm almost there. So, okay, here we go. I'm looking through the phone, so here we go. Wolfgang Pauli was often critical. Heisenberg generally appreciated Pauli's criticism, relied on it, and sought it. Now, what's interesting is what was Pauli so critical about? And you turn the page, because it's the suspense is overwhelming. And Pauli, in a personal visit and several letters, kept Pauli informed when quantum mechanics was developed by Heisenberg, Born, and Jordan. Now, Jordan was the one who emphasized that you have to use noncommutativity. Pauli encouraged Heisenberg, but was sharply critical of Born and the use of noncommuting matrices. Da-na-na-na, right there. How critical was Pauli of noncommuting matrices? Heisenberg did not appreciate that. He wrote a stinging letter to Pauli. So they really get into it, and then Heisenberg challenged Pauli, and Pauli came up with his own solution to what they were working on. So, okay, now to get back to what I was talking about before, I just wanted to point out that the key sticking point that really pissed off Pauli was the use of non-commuting matrices. Imagine that. Okay, so when we get to the imaginary number, now what math professor Luke Hoffman points out is that, or actually this is what Roger Penrose also points this out in Basil J. Haley. So when you have this you have a new definition of time, and so time, instead of time just being t, it inherently has this I connected to it. So when you consider time as a noncommutative nonlocality, then it's always imaginary time, or IT. So I had a paper on this about like the cubic time, but essentially you have this like inherent twist to the algebra of space-time. And since it's non-local, it's actually before space. It's before we can define space with primitive causality, because it's, you end up getting this imaginary phase that's a quantum phase that's non-local, so it's not limited by distance, and that's why it's a pre-space. But it still has the future and the past in it as this non-commutative flipping of the I and negative I, with that gives you the -1 as the identity matrix. And so the key point of math professor Luke Hoffman and Basil J. Haley is that the time frequency is a process. It's an algebraic, non-local process that's inherently asymmetric, because whenever you make an external measurement, it takes time to make the measurement. And by taking time, you have to shift the algebra of the time. So you're always getting this asymmetric time shift inherent to the process of measurement. And it has nothing to do with a limitation of precision of the measurement. It's actually built into the algebra itself as the logic of measurement. And it has to do with the non-local relation of external perception and internal what they call formative cause. So it's a formative cause from within, or mathematically it's called the I can't remember the phrase they use, but so that's the concept that obviously I don't actually do the math, so I'm just trying to convey the concept. And so this guy from Greece, this philosophy professor, he's saying that when you're using 1 as the unit for the matrices, then you can hide the fact that the -1 has this inherent asymmetric, non-local process of the time and frequency from the imaginary number. So even though you can try to say that you can have a inverse identity matrix of I and -I for -1, it's not actually a commutative relation, because as an identity matrix. So that's what makes it non-commutative, inherently non-commutative. So this was made obvious with 1/2 spin, and that's why Pascual Gordon was like dismissed by Pauli. This book proves that Pauli was the one who really dismissed Pascual Gordon about using non-commuting matrices. And so there you go. That gets into the history of it a bit. And I don't know. But the other point is that, like, when we look at Andrija Puharich, I was noticing last night that his whole key quantum biology model is that normally your nervous system operates at a higher frequency. So if you're able to achieve deep relaxation in the theta brain waves, then the frequency goes down to 8 hertz. And then the time would be the inverse of that, as 1 over 0.125. And that 0.125 is actually the inverse of the 8 hertz. But the problem with that is that Andrija Puharich doesn't realize that time and frequency are inherently non-commutative. So he's trying to use radians to convert the hertz to a dimensionless 1 over 0.125 as a time that's just inverse as an identity matrix with the 8 hertz. And so that's why he didn't understand that you have this inherently non-commutative time and frequency. And I try to get into that in my book, There Is No Spoon, but I don't really go into the details about his error and how that's related to the identity matrix, because I didn't really, I hadn't discovered this Greek philosophy of science professor who really clarifies, this problem of when you're trying to, use radians as being dimensionless, for the uncertainty of time and frequency, it's covered up the fact that it has to be 1 as a repetition of a cycle for the angular frequency, so it's 1 over 2 pi. But that process is inherently non-commutative as linear time and frequency. And that's why it's algebraic and not geometric in terms of radians being geometric and as a wave frequency, and the algebraic being a linear time. And so this was covered up in Planck's constant as well. And that's why Basil J. Haley says it's crucial to go to Planck's constant squared to then recover the non-commutativity in the Schrodinger equation. And so here we are back to where we started. The identity matrix, the identity rotation. Let's see if I can get this on film. See if it'll focus for me. The identity rotation is represented by the matrix 1 and not -1. So that's how you lose that inherent non-commutativity. But when you are dealing with 1/2 spin, then you're forced to have that imaginary non-commutativity in the time and frequency. And what that means is you can have negative frequency and time reversed from the future that's affecting the present. And that's what's achieved through meditation then. So it's like this deep secret that's sort of hidden in the mathematics. And let's see here. So, he keeps emphasizing over and over, everything has to commute. Yeah, so anyway, point is to understand the concepts behind the mathematics. And so what is driving the music logarithmic spiral is this concept of symmetry and having the algebra commuting. It has to commute, and that's from the original wrong music theory. That's then called the music logarithmic spiral, and used by Puharich and the Theosophist think tank to try to justify transforming all life on Earth into this techno-spiritual realm of higher dimensional cosmic humanism or transhumanism. And of course that's what we're going through right now with the whole mush Doge, the Peter Thiel thing. And Yeah, so the music, the logic of the music actually predicts the structural drive of the mathematics and the problems that are experienced because of the non-commutativity being covered up at the foundation of reality and the mathematics and the physics and the biology. Okay, so I guess that covers it. I don't see anything else really that standing out. Okay.